a question that concerns many companies. Where do we stand with AI in automation? And as we can see behind us, you prepared a little presentation. So let me ask you, what do you think, how smart are machines today and how do they learn?
Yes, so I will tell a story about how AI will change automation into autonomy. First, I will address how programmers implement software today. So we have a kind of input like this image data here, and we have a program which is handmade. We feed that inside a computer, and this computer gives us output. For example, I detected this cylinder. AI will change that. So AI will have an image data, for example, which is still the same, but it will have the output, which is the aim to detect. And a computer will calculate an AI which can solve this task. So these two parts are called data, really formally. And I can take this AI, deploy it to machines, and transfer the skill. But what will be the evolution of that? We will take a look in the steps, and I will use an example how newborns learn. First, I have in the machine learning domain from data the perception ability. Perception means, for example, regression. I can create the ability, which I have a square, dot, and I can guess what will be the next. Or I can say, wait a minute, in this cluster, I have something different. So it's an anomaly. What we will see also in the machine, which is presented here. Or I can say, how I can detect and separate clusters. I don't know if these are dots or these are squares, but I know I can detect from data, this is different and belongs together, and this also too. After machine learning, I need a kind of memory. This is the step of deep learning. In deep learning, I have the ability to take the algorithms from machine learning and cascade them. And with the cascadation, I can create, with the perception and input data, a multi-layer architecture which can detect, for example, three-dimensional objects, like the cylinder, the cube, or even a face. So each layer of that has its own task, detecting a small piece of the whole. On deep learning, I have the challenge that I need a lot of data. So how I can create a lot of data, how I can create, for example, dexterity, solving a task. If I have to teach a lot of years, which was made, for example, by me in my lifetime, how can take this time back? And in this point, reinforcement learning comes into the game. So in the reinforcement learning, I have, after the perception or memory, the dexterity which is created. If I couple together an actor, an AI, but also the task. I can do it in the simulation with a digital twin. For example, with this cylinder, placing that on this cube. And I can learn lots of years of evolution, what I have also learned as human, in the machine way, but I can learn that in a really fast time. If I want to transfer that to the reality, I can take this AI and put it in the reality, and I can do the same task as learned in the simulation. Here I have the problem that if I just little change the task, I need a completely new training. Actually, the state of the art in AI is solving the challenge of transferring the intelligence. So this is called transfer learning. And it is the point of, after I have perception, after I have memory, after I have dexterity, I need a kind of abstraction. And abstraction means if I teach one time's machine to place the cylinder, I can also transfer this skill, for example, to place that form also like this. And this will be the last step for autonomous machines.
Thank you for the insights, Mr. Satikidis.